Hello there, welcome back to the great adventure and searching for answers to the question of the user assist info. I don't think I need this private path. Thought I did. Yeah, if you recall from, let's see. Oh, probably when you were about 6 or 7 years old when I started on this. The Windows 7 comes equipped with something called UserAssist, and it's I don't even know what it does, really. Somehow it maintains some historical information about what's happened, at least with the shell, and I suppose that it uses that in order to make predictions about what you might do next. For instance, it might decide whether or not to put this here. Now, I just cleaned my thing out, so it's not very revealing, but I think I've pretty much broken down the structure of the little information block, except for, well, these two I'm a bit confused about. They definitely have to do with running a program. Now, if you look at MS-Dev here, this counter has been going up and up and up. It's no, I should keep a copy of these things. Well, forgetting about that, let's look at something like this. First off, I'm pretty sure about this number, meaning the number of times that the shell program has launched this program. Alarm that happens to be running right now in here. If I close that program, okay, and I got to restart. I need some kind of refresh. Run it again. Click on this. It's the same too, right? Yeah, never mind about this time. Yeah, I'll tell you about that in a minute. Okay. So now I'm going to run it. So start up here. I run it. Now I go look again, and now it's gone up to 3. You see? Now this program, which is the program that's been printing this out, has 0 for that number, but it's got a big number for this, which goes up. It's currently 33. I'll close it, and I'll start it again. Well, it might take a while. I have to pick it out. No, it's still 33. Is that the right program? Yeah. Pretty sure it was going up before. Okay, well, it's stuck. Now this is, oh, I see, now this has gone up to 50 though. So it seems to be taking those launches as something this program is doing. That would make sense. But where did the other 33 come from? That's one more, you see? And this is still 33. I'm very confused about this one. I've said events, and that's all I know. Because it's evident that I'm pretty sure this is a counter. The way I determined this layout, by the way, that everything happens to be D words, is, well, it may not be true, but I'm pretty sure they are. These are D word pairs, and I'm pretty sure it's either just a single D word and only flags, but I doubt it. Or some portion of it is flags. See this BF80. Whenever these things are not being used, you see BF80. Okay, now it could be that every bit following that last one with the 8 is data, because sometimes you'll see 3F80, right? And then sometimes you'll see 3D something, right? And so if these appear to be flags, when this is a 3, it appears like there's information in there. This might have to do with what kind of information, and the rest I don't know. Now these are all unused currently for all of these programs. And the reason is, see now, command is another one. Close this. Now I start command this way with this link here, right? And that link should be for command.com. I don't want to run too many programs. I'll check in a minute. One of them is command.com and one of them is that other funny thing that doesn't show up in here. Now I think that was 5 before, it's gone to 6, and this has become 9. Well, I think it was 8 last time. I think they just both went up by 1. That's why I need to make my own history. Let's try it again. Close this first. Exit this. Run it. Try again. Aha! Now see, that went up to 10. And I didn't launch it. I closed it. So maybe this is code, run and stop or something like that. And other things. It's got to be other things as well, because this thing has got 55 of them going, and not a single one here. But anyway, I do it again. They should both go up by 1. And they did. Oh, no, they didn't. Yeah, they did. They both went up by 1. This you'd think would be double that. However, at one point I killed Explorer and restarted it, and I think it recorded an extra 1 just for, no, it couldn't have. It probably didn't record the stop for the one that after I killed Explorer and started it again. that would make sense. Yeah, the way I worked it out was I used this little inline tool called trace buff. Now see, it would probably be better if I put the old one back, which I didn't get rid of. So let's get rid of this one. Try to keep them in sync. Alright. Now I don't want to just run Explorer directly because I don't want to give it my environment, but I have my fixed sys, which will restore the environment to the basic one, and run it and kill it and run it again. But that won't matter. All I want you to see is the previous things that I had. Okay. Now, I'm wrong about this one. Sometimes this is one less than this. Now you see this 5. I believe this is the number of days running that has been running anyway since it began doing its thing. Okay, now if that's true, 5 days running, 1, 2, 3, 4, it's on the 6th day, and it's recorded. This is the history day by day for this particular program. Okay, now I'd have to check this at a different day. You'll see that these all start with 3. This I've seen as B, E, F, mostly 1s, high numbers. These numbers, I don't know, seem like they can be anything. And again over here, if it's going to, there only seems to be one bit of information that it could pop. Well, 3 bits. There's these 2 numbers, or it could store, right? And then this counter thing, which I don't think actually, I got it as a D word, but it probably only goes up to, I've only ever seen it very well. It's 5 bits. In a single day, if suppose this counter is in system time units, and it's a time type thing, right? And it has to do with process execution time. Then there's a limit. 1 day is only a certain amount. There's a maximum it could possibly be, and it'll never get near that maximum. There's 1 day as file time. Oh. Might be in the wrong file. Oh, here we go. 1 day. Now that's hex. Sorry, that's decimal. What is that in hex? Oh, okay. Excuse me. This is where I was building my trace thing I'm trying to explain to you. But let me just see. I'm curious to know. Word. QW 1 day as file. System No, okay. Now there's a file time structure. And it's structured low then high in reverse order in the natural way. So that would be this value, the low part first. 1, 2, 3, 4, 5, 6, 7, 8. And then the high part, well, actually, I don't know why I'm doing it like this. I could just have printed them out separately. No, 0, 8. Okay. Low then high. No, high then low. Just want to see the map and see if there's any high, if high is 0 or not. In which case it all fits, one day fits in a D word value, and maybe less. Or it could be ticks. Maybe we'd save that thing as ticks, which is a, no, it's not. Let's see. So that's one day. It's more than a D word. That's quite big. But nothing. I mean, if that time, if the value that it's printing out there could be running time, or it could be processor time, which is a much smaller number. Well, if you look at processor time, CPU time for things, is nothing. This one, the maximum is 23 minutes, right? For this session, which is, I guess, not that long. I rebooted. But still, it won't get very high. Elapsed time, though, it's big. That's the, just the time that's been running. This is the amount of processor time used. And one or the other of those things is being maintained. If I've got to convert this to seconds. And, well, let's see. Let's see what those numbers are again. Now that's been run. If that's a time value, and it probably is, it's going to be bigger the next time, even if I do nothing. So currently it's that. I can only take snapshots of this. But that's the same. So it says, but it may not write that value out every, all the time. It might only do it when some kind of event occurs. I could do that. But I'm curious to see if it just goes up on its own eventually. The same. Well, it could be processor time then. If this doesn't change and it's No, it's got to be using some processor time. It's running, right? Four 978. We'll close it. No, okay. Now it's still the same. Okay, now it's changed. Now it might just be that it only does that. It only does that. It didn't add very much to it. It might only do that either once in a long while or if some event occurs. And there's 4 digits. Yeah. And the difference here is not that great, right? It added 1,000 something hex. Where's command? 0.2, that could be 0.202 seconds. 1,000 hex is 4,000 decimal, and in file time units, it's 100 nanoseconds per. So that's 10 to the minus 7 times 1,000, 765. Right, so 10 to the minus 5, and it's 4,049. It's less than 1/3, about 1,000, let's say. 1,000 hex, it's 4,000 decimal, times 100 is 40,000 nanoseconds, right? And that's 10 to the minus 9. All right, 876. Five, 4. 3. 0.4 times 10 to the minus 3. 0.202. Still about the same. And this is yeah, that's right. Well, no, it's off by it's off by a factor too. This is but it's less than 1,000, right? Let's figure it out exactly. 2 decimal minus 3,058. So that's 0.306 second. 0.306 milliseconds. Isn't it? Yeah. No, that's not right at all. What about this number? If that was seconds, suppose that we wanted to write this number, which is no longer the one that it would be. Previously it was 47. That was still quite a bit after running it. But anyway, 47 seconds is 40,000 milliseconds. So it could be milliseconds. It could be a millisecond value. Let's see what it says this time. It's running. See what it says next time. Oh, I have to get it on a change. Oh, it is changed. It has changed. $16,000, 160,000, let's say milliseconds, which would be 160 seconds. 160 seconds is just less than 3 minutes. Well, that sounds about right. Right? So it seems to be recording this time. Okay. So if that's true, then it's recording that time in milliseconds. 1 day in milliseconds is more than 1 D word. It couldn't do it in this number of bytes. So this counter, this thing, must be actually smaller. The way I got the alignment, no, but it can't be smaller. There's only a certain, the way I got, oh no, it could be, yeah. The alignment that was using this magical trace buffer thing that I invented, just for solving this problem of trying to determine the structure of structure. What I wanted to do, well, I'll do the trace from 0 on any one of these things. Cell change, raw data, okay, all right, when we're in here, if trace buff, I need another F. It's in a registry or something. Set that to false, set this to true. So taking it 10 bytes at a time, I'll just show you what this traces out. I'm just tracing the buffer out, 10 bytes worth, first as D words, then as words, well, first as bytes, then as words, and then as D words, at every possible alignment. So if we take this here, okay, here's the buffer, the first 10 bytes. As bytes, you get this. As words, you get a 5 here, a 6 here, in this slot, a 63, and then something like that. As D words, it looks like this. Okay, now the D word theory looks pretty good. And I wasn't sure, this might be 2 words, but this definitely looks like D words. There's a 5 here, 5 should be in my list there. Okay. Oh yeah, it is 5. It is day 5. Yeah, this is the old one. Now if we look at something else, like this one. Now the theory of the first two being D words looks good, right? If it were D words aligned here, then it's messed up, right? You just go to a different one. Actually, that one's the same. Yeah, it's something with some data. They don't all have data. Let's see, this is A. It doesn't look right, 7F something. Nor any of these other possible alignments. They don't look right because they vary too much. See, in the last, this one here, for here, 37F. Well, that's the same order of magnitude. Well, D words are going to line up pretty good, I suppose. But I bet you'll get a weird one. It's always having zeros here, right? Doesn't look like a D word there. But these three being small D words looks good. And this here, as words, you'll find that these last two, either this is a D word with a small value and a large value, or it's two words, one small value and something that's kind of random. But it looks more like, because this part varies quite a lot, and this one doesn't. It's small and it stays small. It's not likely to be two words. See here this, well, it's a small number. Unrecorded. Okay, small and 0. You don't see the very last one being very, very big. If you can get something. Okay. 905 and 0. This number changes quite a lot. You'd have to actually make a graph, and to do it properly, you'd have to get a great big sample, which I don't have, and run through it and check the variance of each of these things for the various possible alignments. Like you would say, looking at this as a word, how much does it vary throughout all the samples? And if it's going up and down and it's all over the place, then it's probably not. It's not likely that this is a word value. If it has like a random, if it appears to be sort of a random number, not like close to some peak. But if you put these two together here, then you'll get a better distribution. And nothing aligned this way looks any good. And we've already checked this one. As words these are always 0, right? So why are they always 0? It seems like they go together with the other one. And the other thing is, if you keep, if I keep doing that and keep adding more and more, this is an offset. You find keyword values appearing with similar, like quantitatively the same, starting at offset 20. Here, these BF8s, okay, either you're going to get 3F something or 3D something something, or BF8, and that's all you get. See? I started at 20. BF8, sometimes it's 0 too, that's a possibility. Here, 3E something and BF8, BF8. BF8 seems to be like unused. If I go back a little bit, let's say 18, you can see where that business starts. I think it's, yeah. Or I could go 20 bytes, or this is the length, 16 decimal bytes. You should be able to pick off at least 2 D words worth of repeating pattern. Okay, now here's a 3F something something, 3F8 and 0, 3F5, and now BF8 seems unused, right? And it's going to be BF8s all the way down to the time value. That's what I found. 3F80 seems like used, but there's no data. Here's a 3F. This, if that is a top bit, if the top bit of this nibble indicates that there's data inside here, then that would make sense. So this becomes 5, and so the remaining bytes are some data. That might be true. See, that's true for this one. It's true for this one. That bit, the top bit is 0, and then there's data. It's true for this. You see? D, 3D, oh, it's not true for this one. This certainly has data in here, but the top bit is non-zero. So, okay, that theory is not right. But who knows how it works exactly. But there's only one bit difference between BF8 and 3F8, which is what made me think along those lines. Seems like the top bit says, yeah, unused. But I'm not sure, because there's another thing. The way it's laid out, if my theory is correct, is that each process that this user assist knows anything about has some information in this structure pertaining to the current day being recorded. And then there's a table of historical bits that goes back 10, possibly as much as 10 days. Okay. if I wrote these out as D words, you would see it much clearer. You see data, 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 and then BF8, right? And if I waited till tomorrow, this is the current, I believe this is the current number of days running, right? Now this, I thought this might indicate where the next free slot is here. But actually what this might indicate is which slot to start reading from. Like it's a circular, it could be a circular buffer. Because there are some, you'll see, that don't have 0 there. If I can find one. I think they were near the bottom. There wouldn't be any of these. There wouldn't be anything like that. See, that's got 2. And these are empty. I would think that this would indicate that. But maybe BF8 indicates it. You know, you don't need that extra 5. I'll find one. Just to show you before I go. Oh, sure there were there was some 4 in there. I'll hit one eventually. I think the ordering is old. I don't know. It could be because it might have cleared all those out because that registry was copied in. Shouldn't know. I'm certain I've seen it. Okay, so they must have got 0 out, I guess. I don't know why. So I was seeing a lot of 5-4s, and that made me think, yeah, so it's been wiped out. This last one sometimes is a 4, was a 4. I should have saved it. And so actually, even though this might say days running is 5, I bet that it's going to store its next information here. See, now these say 3F8, but it looks like it doesn't have anything for these days. These have not been used yet because this is a 5. This is the next place to start. I'm not exactly sure about that. 3F8 and BF8. But it looks like there are 2 days of recorded data for this particular thing. And, you know, I'd have to wait till tomorrow to see what it puts in this slot. But it definitely looks like 10 slots worth of stuff. And I've determined what this time is. That this time is the first time that this shell, I think I already said, executed a program. These normally they start out as 0, and they will remain 0 until you launch something with the shell. Find a 0, 1. These are launched through the start menu. Auto runs, no. Okay, here's this. I just ran at the command line, right? And its time is 0. Gosh darn it. Now it should have recorded that time. It should put the current time in there for that auto run. Auto run. Let's check all the icons are correct now. Yeah, where's auto run? Where is it? I'm looking at the icons. Auto runs. Here. There. 23:55, 21st. So now that date and time will never change. That's fixed. So everything, any times recorded would be with respect to this time. If I run it again, it won't. This time doesn't change. So I know what that time is. And now it's got this here. It didn't have anything before, I'm sure. And the counter thing is some little value. And this must have been there before. There are some zeros here. I don't know what that means. Okay, anyway, just thought I'd let you know that I'm trying to make sense of this structure. And I think I have it at least down to it, almost the structure. I'm sure these times, I'm sure this is a table, a history table with 10 entries. That's almost guaranteed to be true. And I don't know about this last one. Sometimes this is one less than that. And that might only get set once it sees a date. Once it sees 24 hours rollover, it might put that as the last running day when it was doing its thing, I guess. I don't know. Okay, that's what I know.